Okay. Yes, good morning. Welcome you all to the Day 5 Arduino lab class. First we will see if you see this screen, this is our actual task of Day 5 class. But before entering into this class, we will recollect the last class portion. Then we will immediately enter into our today's class session. So in last class, I hope everyone remember, we learned PWM technique. In that we did few experiment. One is vary the brightness of the LED by reading analog input value. And the second one is display any color using RGB LED. The third one is display all colors. Okay. So these are the three experiments we learned last class. So by reading analog input, we made the LED brightness to vary. So this is our first exercise, what we have seen last class. The next one, any one color at a time we can make it to appear in this display. Then the third experiment is making multiple colors, all colors. Okay. Now we will come into the today's class session. Okay. So here the theory portion already you may aware of it. Don't worry about it. Everything we are going to do it in our demonstration class. Now liquid crystal display. What are the experiment we are going to do in this? First one, display hello world. Then enable cursor and blink it. Third one, turn on and turn off LCD display. Wait. Something went wrong. So is it okay, sir? Hello?
தெரியுதுங்க சார்.
தெரியுது sorry.
Yes. So then fourth one, set cursor and print. Then print continuous value on the LCD. The last one is read the switch status and display it. Okay. First we will see the hello world experiment. Please observe this video. So this is the hardware setup what we are going to make it. So this is our Arduino board. This is our LCD. So whatever the pins are taught, please observe in the video all the 16 pins. You no need to bygot anything. Just bring the cursor nearby the display. It will show all the pin names. So out of 16 pins, we have used only few pins. Okay, what are all the pins we have used? By seeing the wiring diagram, it is simply you can observe what are all the pins we have used. Okay, so the back LED, data pins, control pins and power pins only we have used in this. Okay, then what we are going to make it in the output display. So this is our program. In this we are going to simply print the message called hello world. Okay, so here today we are going to, very first thing we are going to make the, say as like in our C program, here we are going to print the hello world message. For that we will see the program part. You may aware of these things very well, so I will rush up little bit. So the first one, I need to initialize the header file, then I need to configure the pins, then instant of class I need to declare, then followed by I need to set and configure few things. That is, what is the size of the display? It is 16x2. In LCD.begin, I will declare it as a 16,2. Then LCD.clear. So initially, if you are having any display, if you want to write something, we will clear the display because the old value should not disturb the new thing. So I will clear the display, then I will start print the required value. Okay, so in void setup, what we are going to do, we are going to initialize the display, then clear the display, then see this hello world statement, you can print it in void loop, or else simply we can print it in void setup itself. Okay, so very simple. Write the header file, then configure the pins, then configure the size of the LCD, clear the LCD, then start print the command. Now we will come to the lab.
Gajendran, PowerPoint வந்து அந்த இது டர்ன் ஆன் ஆயிருக்குன்னு நினைக்கிறேன். கீழ அந்த சப்டைட்டில்ஸ் அது வந்து தப்பான வார்த்தைகள்லாம் சொல்லுது.
சார் பவர் பாயிண்ட்லையாங்க சார்?
பவர் பாயிண்ட்ல கீழே சப்டைட்டில்ஸ் வருது.
சார் சப்டைட்டில்ஸ் மேபி இண்டிவிஜுவல்ஸ் ஆன் பண்ணியிருப்பாங்க சார்.
ஓகே, தேங்க்யூ.
Hello. Okay, sir. So shall I come to the lab session now?
யா ப்ளீஸ்.
Yes. So for our today's experiment, Arduino board, breadboard, then one new component. Can anyone tell what we need to get from the new component? LCD. LCD is an input device or output device? It is an output device. Come to output device, then select your LCD. Okay. So here we are having only 16x2. There is no other variable, and also it is a blue color back display. Okay. So let me keep my LCD. Before keep my LCD, let me power my breadboard first. As usual, plus and minus. Then ground wire. See, if you want to power the top layer also, simply take the wires and connect it. So now this line also become positive. Take this, power this one. I hope it is clear for everyone. Now I will bring the LCD. Okay. Yes. Now, please observe in 16x2 LCD, we are having 16 pins. So one by one, I am going to connect it. Before that, I am going to connect all the pins into my breadboard. I'm going to connect all the 16 pins into my breadboard first. See, only first experiment will take little time because hardware connections are little more in this. Please observe. Then we will make the duplicate of the circuit and we will do all the remaining experiments. Okay. So now successfully I have connected all the 16 pins of my LCD with my breadboard. Then one by one we will start give the connection. We will start from the power pin. So the first one is ground. So ground, simply I can connect it over here. First one is ground. Then the second pin, please observe, here it is written as power. That means VCC, power. Okay. So first one is ground, the second one is power pin, we made it. Then what about the third one? It is a contrast pin. Contrast. So how I need to connect the contrast pin? Finally, we will see. Before that, what are the pins? Register select and read bar write. So read bar write, since I am going to write the values into the display, simply I am going to keep this pin as logic low. So whenever you make the write operation, you need to keep this read bar write pin into logic low. Then after that you have a enable pin, then you have a data pins. At last you have backlight. So backlight, see here, this is the anode terminal of your backlight. So I'm going to take the anode pin and connect it into the VCC 5 volt. Then the ground pin, cathode pin, I am connecting into the negative. So this is backlight. So this is anode pin, this is cathode pin. So see the connection. Is it okay? So now we connected VCC and ground, then read bar write, then backlight. These 5 pins are nowhere related to our program. The remaining pins, based on our program configuration only, we need to connect. For that, let me refer our program once. Come back to our program. See, these are all the pin numbers. Please make a note of it. I am going to use second pin is for register select, third pin is for enable, eighth pin is for D4, ninth pin is for D5, 10th pin is for D6, and 11th pin is for D7. Okay. Now what I'm
Please,
going to do,
please write it down. Please write it down. Somebody write it down in your notebooks. Gajendran will not repeat.
please make note of this order. Please make a note of this order, because the same pin connect configuration we are going to use it in. See, I posted in chat box also. Please refer. Now I am going to connect one by one. First I will take register. First I will take register select. So register select, as per our program, I need to connect it in pin number 2. So this is user defined value. You can choose any one of the digital input and output pin. So first I have connected register select pin in pin number 2. So what about the next control signal? Read bar write, already we made it into permanently logic low. Then what we are going to connect? Enable. As per our program, the enable pin, we declare the enable pin as pin number 3. So for better appearance, I am going to change the color. So what are all the control signals we have connected? Now we have connected register select in pin number 2, then enable in pin number 3. What are all the other 4 pins? Data pins. As per our program, the data pins start from D4. Where is D4? Please bring your cursor. This is D4. I need to connect D4 to which pin? Can anyone please unmute yourself and tell where I need to connect? D4, I need to connect it in pin number 8. Very good. Pin number 8. This is the first pin. Then remaining pins, simply you can connect it the successive pins. So because we choose the pin numbers such a way that 8, 9, and 10. So we have connected D4, D5, then D6 in pin number 9, D6 in pin number 9. Pin number 9. What about the last wire? It is D7. Simply take the D7 and connect it in pin number 11. That's all. Can anyone tell what are all the wires left?
Gajendran, can you please make all the data pins in the same color, Gajendran? So that
Sir,
it is
data
easier.
pins?
All data pins in same color.
Oh, okay, sir. No issue.
So that they will know that all the data pins have been marked in same color.
Yes. We will make it into red. Okay, all the data pins, I'm going to make it into red. Okay. So the second pin is what? Register select. So if you want to have an annotation, please click this one and keep it here and type it register select. So the second one is register select. Simply Control C and Control V. This is my enable pin. Enable. Okay. So this is register select, then enable. What about the remaining 4 pins? 4 pins are my data pins. Start from D4 to D7. Is it clear for everyone? So now we made the hardware connections. Few connections are left. Can anyone help me to finish? We have connected power pins, VCC and ground. Then 3 control signals, then 4 data lines, then 2 backlight. What is the one more control signal left? Can anyone tell? Very good. It is contrast pin. The third pin contrast pin. Straight away I can't connect it. I need to use the potentiometer to vary the contrast. Okay. So potentiometer fall in output device. Come to output. Find where I am having potentiometer. Sorry, input. Potentiometer is an input device. come to input device and take your potentiometer. So typical value of the potentiometer, what we are going to have is a 10 kilo ohm. Please make a note of it. Whenever you are doing LCD experiment, you must buy this potentiometer. Okay. So in that, I am going to initially power my potentiometer. I am going to power my potentiometer. Very simple. See, the outer terminals, terminal 1 and terminal 2, usually we will connect it across 5 volt supply. The third terminal is the wiper arm. So as per our circuit diagram, from the output terminal, the wiper arm, from the output of the wiper arm, I need to connect it to the C. From the output terminal of the wiper arm, I need to connect it to the pin number 3. So now I will connect this in the same way. Take the contrast pin and connect it over here. Okay, is it visible? So I make it into red color for a little more. Please observe once again what are all the pins we have connected. The first one ground, the second one power, the third one is the contrast pin that is connected in the output terminal of my wiper arm. Then you have a register select pin, then read bar write, then you last you have enable. That's all. After that you have 4 data pins D4 to D7. Why we are using 4 wires? Since we are going to operate in 4-bit mode operation, we are using 4 wires. At last, the backlight. So backlight, this is anode terminal and cathode terminal. Then what is the second thing? I need to start type the coding part. So come to the coding part, select text. Select text. By default, you have a blinking program. Please delete this one. Please refer your existing program. First I need to declare the header file. I need to include the header file. Include liquid crystal .h. Please make note of the syntax. It is case sensitive. L is capital letter, C is capital. Okay. .h means it is a header file. You know, we are aware of this one already. Liquid crystal. Okay. This is in the first declaration. The second one, after including your header file, you need to write the instant of the class, then pin numbers. Okay. First I am going to write the class name as liquid crystal. Liquid crystal. Then instant of class. Here initially I will keep it as LCD. Then we will change and check it. Okay. Then pin numbers. Pin numbers in which order we need to write? The first one is register select. So register select, please refer. The pin number is 2. Simply type 2. Then the second argument is the enable. Enable pin number 3. Type pin number 3. Then data pins start from D4. So D4 is 8. Then 9, 10 and 11. Type 8, 9, 10, 11. That's all. Then put semicolon. Don't forget the semicolon. So this is class name. This is instant of class. Hereafter, in your program, we will call only this instant of class. Instance of class only we will call. So very first thing, what I have to do, I need to tell to my microcontroller that I interfaced 16x2 LCD as my hardware unit, because by default, it will take a 16x1 display. So if I not configure this line, the second line won't appear in my display. For that, I must declare this LCD dot begin 16, comma 2. That's all. Then before writing anything, what we will do, we will erase the previous thing and we will write the S command. So clear. That's all. So 16 cross do display, we have declared 16 cross 2, 16 cross 2 LCD. We are going to use it. Then clear
As
the
Gajendran
display.
describes, please make note of the functions available with LCD.
Yes, sir.
Already there are two functions, LCD.begin, LCD.clear. Please
Yes.
write it down in your notebook. You will need
Please
all.
make note of this syntax. Please make this syntax. Okay. Now, what is our task? We need to print one message as like a serial monitor program. LCD dot print. LCD dot print. Within the double quote, whatever the statement we will type, it will get appear in your display. See, hello, comma, world. So this is all for numeric display, all the alphabetic and numerical value along with special characters. See, I typed a few special characters, comma, space. Okay. So all the special characters you can make it into display. But this double quote won't get appear. I hope you are aware of this one. So within the quote, whatever the message we are passing, that will get appear in the display. Okay. So please go through the program once. This is my
Gajendran,
header file.
somebody will have a doubt why you are printing it in setup, why not in loop.
Sir, that I will show. See,
Yeah,
see
please.
here, listen, here, only one time we are going to print. We are not going to update the display command. So message, only one message I am going to print. Therefore, I am keep it in void setup itself, only one time. If repeatedly I want to update the print statement value, obviously I need to keep it in void loop. Okay. See, if I keep it here, only one time my program will run. In void loop, it is a dummy, nothing is there. So please come to the simulation part. Now you appear, now please observe this display. We made one mistake. Can anyone tell what is the indication? Can anyone tell? The star with the red mark. That means, can anyone tell what is this indication? See, likewise, you have some alert message. Your display will get damaged. Here, your display damaged. Why? What is the condition means? Our backlight, we are connecting straight away to the 5 volt. Backlight is nothing but on LED. I need to use current limit resistor. Even with the LED, tricolor LED, any device if you use, if you are not using proper voltage, this alert, this damage alert will come. See here they are giving a message, see, current through backlight LED is, now it is 23.7 kilo ampere. See, I will zoom and show you. See here, now the current flows through the backlight is 23.7 kilo ampere, while maximum is only 20 milliampere. How I can reduce this current? Come back, stop your simulation, get the resistor, give the value as 220 ohm, Now I am going to take the resistor in series with my anode terminal. Now I will observe, this is my VCC, From the VCC, 220 ohm current limiting resistor. After that only I have connected to the anode terminal. Is it okay for everyone? Now you start simulate and observe the output. Perfect. Now, what is the function of this contrast? Please listen. If I vary the potentiometer, you can see the contrast variation. Now, hello world statement along with some back character. I don't want those character to appear. So I'm going to adjust the contrast. Is it okay now? Is it okay? Likewise, by adjusting this voltage, the pin number 3, contrast pin, By changing the input voltage to this pin, we can adjust the contrast of your display. Okay, that's all. First exercise over. What will happen if I keep the statement, that print statement in void loop? We will check once. Now I remove this statement. Now I will keep it over here. Please observe this. Please observe here. Repeatedly it gets prints. Okay. Void setup means only one time. Void loop means multiple times it will get print. Okay. To avoid this one, what we have to do means we need to set the cursor position, then we need to print. That thing we will learn later. Okay. Now at this point of time, you forget this one. Keep the statement in void setup and observe the output. Once you know the remaining syntax, then we will do the void loop function. Okay. Now I'm going to stop my simulation. We will come to the second exercise. I hope this is clear for everyone. If you have any doubt, please type it in chat box. So hello world program we have completed. Then now you come to cursor, enable the cursor and blink. Please observe, sir.
You take the entire time for the last 5 minutes alone. Give it to me, Gajen.
Okay, sir. Okay.
I want to address that absence and the.
Yes, sir. Okay, sir.
So you can take the entire lap time, right?
Okay, sir.
Last 5 minutes,
okay, sir. See, enable the cursor and blink. See, whenever you use the calculator, while we typing the character, we may find the cursor. So cursor, now we are going to make the cursor to on, and we are going to make it into blink. So there are inbuilt functions available. So in remaining all the program, the void setup and the initialization supports remain same. So I won't explain every time. Please remember this is common for all the experiment. So straight away I'm going to the loop portion. Before that, see the animation, what you are going to see in your output. See, can you see cursor on and at the same time it is getting blinking? Now we will do this exercise. See, cursor on and blink. Please observe the animation. Cursor on as well as it is getting blinking. Now we will do the exercise. Come here. Void loop. Simply I'm going to write the function called turn on the cursor, then blink the cursor. Turn on the cursor. Please make a note of the function LCD dot cursor. Then how to blink the cursor? Again another function LCD dot blink. Now you come to our lab portion. Come to the simulation part. Come to the program. Here I am not going to type the hello world statement. Let me uncomment this one. Now, what we have to do, the initial thing, everything is similar. Only in the void loop, I need to make the cursor to on. Cursor to on is nothing but LCD dot cursor. That's all. LCD dot cursor. This is nothing but on your cursor. That's all. Then blink LCD dot blink. That's all. This is to make your cursor to blink. Okay. Very simple function. These are all inbuilt functions. Once you include this header file, then only these functions will be in active. Okay. Now I am going to start simulate. Please observe cursor on and blinking. If I uncomment the blinking action, if I comment that line, only cursor is on, no blinking. If I want to blink, then I need to include the second function name called blink. Okay. See, we must know once you turn on something, how to turn off. I must know. So in the same way, if I want to disappear the cursor in my display, what I have to do? First, we will try that one. So I'm going to make the cursor on for some time. Make the cursor on for some time, off for some time. How to turn off your cursor? Please make a note of it. Dot cursor means turn on the cursor. To make the cursor to off means no capital letter cursor. CURSOR. That's all. No cursor will make your cursor to off. Off cursor with some delay. See here. Please observe. Can you view the output over here? Cursor is on for some time, off for some time. Is it okay? So there are simple functions. Please observe the syntax over here. Cursor, simply cursor means on the cursor. No cursor means turn off your cursor. So these are all the inbuilt functions. Make use of it. Okay. Then in the same way, how to turn off the blinking action? Shall I delete this portion? Is it clear for everyone? How to make the cursor to on? How to make the cursor to off? Everyone knows. Now, what I'm going to do, I am going to show how to turn off the blinking action. See, stop your simulation. Stop your simulation. Come to the blinking program. LCD.blink. Blink for some time. Again give delay. Again give delay for 1 second. How to make your blink to off? Very simple. LCD dot no blink. B capital letter. Please observe. B is alone capital letter here. No blink means will make your blink to off for some time. Please observe. See, this is to make the cursor to blink. No blink means off your blinking action. Okay, now you start simulate your program and check it. See, blink for some time, no blink for some time. If you change the delay, you can view this one very clearly. Let me remove the cursor command also. 2 seconds, my cursor won't blink. See, 1 second it will blink, 2 seconds it won't blink. So there are simple functions. Please make a note of it. Please make a note of it. These things very helpful whenever you are doing the project. These functions we will use it. That's all. So what are the things we have seen so far? So far we have seen how to simply print the command in the LCD display. How to simply print the command in the LCD display. Then how to enable the cursor and make it to blink. And the third exercise, come here. Third exercise, turn on and turn off the LCD display. See, whenever you are doing the project, 24/7, you no need to make your display to on. Whenever necessary to read the value, whenever you are going nearby to the machine, at the time only I want to make the display to on means there is an inbuilt function called no display as well as display. Now see here, in setup program, I'm going to make the hello world to print and I'm going to control the display using these two functions. Please observe the animation. Please observe the animation. No display means we will turn off the display. Here delay is 1 second. Simply display means turn on the display. Now you see the output. The hello world not going to appear continuously. Please observe here. Hello world on for some time, off for some time. Thereby, you can make your power consumption low in your project. Whenever required only, display will get appear. Shall we do this one? Very simple program. The initial portion, we need to print the statement hello world in the void setup, then come to the loop, the new two functions name called how to turn on the display and turn off the display. So turn on the display means simply display. Turn off the display means no display. Yes. Please make note of these two things. If you want to turn on the display means LCD.display for 1 second. To turn off the display, no display. So no, after that capital letter D. Observe this syntax very clearly. As like a blink and cursor, to off the thing, you need to write no. Then immediately the particular function will come with a capital letter. Now you come to the exercise. So here I am going to print the statement hello world in my void setup. Then I am going to control the display. How I am going to control? Come LCD dot display. LCD dot display. How long? I can set delay for. Sir, is it visible, sir? Sir?
Visible, Gajendran.
Okay, sir. See, display on for some time, off for some time. So simply no, this D must be a capital letter. Okay. To differentiate the on and off time, let me change the delay time. Now you see the hello world statement. Now I am going to make it into on for some time, then off for some time. These are all very simple inbuilt functions. See, 2 seconds, no display. Only 1 second, we will give the display. These things you can write it in any conditional statement also. You can write whenever I press on push button, my LCD display has to on. Likewise, you can do the thing. Okay. And one more thing, for this power pin also, the backlight also you can control using your program. Because the backlight, again, we are going to use 5 volt DC supply only. Instead of connecting straight away into the VCC terminal, I can connect it into the any one digital pin and make the backlight to on. Can anyone tell when we need to turn on the backlight? During daytime or nighttime? Daytime, no need of backlight. Without backlight, you can view your display. During nighttime only, I require backlight to on. So you can program that also. So this VCC straight away I no need to connect. I can connect it into any one of the digital pin and I can program it. Whenever I would want to turn on the backlight, at the time only my backlight will get turned on. So I will recollect one thing once again. So what are the things we have seen so far? We have seen hello world to print in our LCD display. Then cursor on and blink, cursor on and blink. The third one what? Turn on and turn off the display. Shall I move to the fourth exercise? Do you have any doubts so far? Please type it in chat box. Please stop us. Now, set cursor and print. What is mean by set cursor and print? So as sir told already, the dimension of this LCD is 16x2. Where I need to start print, whether I need to start print in my first row or second row, that is the row selection. The second one is the column selection. In which column I need to start print. Okay, here in this program, in this animation, you observe here we are using the command called lcd.setCursor 2, 0. Please make a note of it. The first one is the column number. 2 is your column number. Let me hold the program once. See, the 2 is your column number. 0 is your row number. Please make note of it. Set cursor, column number, comma, row. Then immediately I am going to print the statement. Then I am going to introduce one delay. I will tell you why we are introducing delay at the last. Okay. Now you see the output. What is the output we are going to get? See, now my Arduino class not start printed at the 00. The first column la print agala. Rendu column move ayi third column la print agadu. Okay va? Then but also it is printed in the first row. So how we can set this cursor position? Then we are going to print. That we are going to see now. See, as usual, the void setup program, everything is simple. Now you come to the loop and make note of this. Please make note of this. Set the cursor in third column and first row. Please make note of it. I am going to set the cursor in third column and first row. Okay, then I am going to print the message. Then I am going to give one delay for 1 second. Okay. Now what is the equivalent program here? Come back here. LCD set cursor. LCD set cursor is the function to set the cursor position. 2, 0. Can anyone tell? Here I have written third column. Why it is 2? Can anyone tell? Here the column number is 3, but I am mentioning into 2. Why? Because my column number starts with 0. First column is represented with 0, second column 2, third column 2, fourth column 3, and so on. Here the starting number is not a 1. This consider your LCD means first column address is 0. Second column is 1. Please make note of this difference. In the same way, row, first row, we will address
Lot
it
of them
as
have typed
0.
correctly.
Sir?
Lot of them have typed correctly.
Okay, sir. Thank you, sir. See, in row also, first row means 0. Please read the statement. First row, declaring it as 0. Okay. So the actual value -1. That's all. The actual value -1 we have to type whenever you are going to address this. Okay. Now you come. What is the statement we are going to print? LCD print Arduino class. Shall we try this one? And the last point, why we are introducing delay? See, in the LCD also, we are having the LCD consists of microcontroller. The microcontroller will take some time to process these commands. See, this is called command. This command will make your cursor to appear here. Then we will send the data. This is the data we are going to print. To make these functions to happen, we are going to give some delay, because in void loop, infinitely the function going to happen. So at that time, rapidly if you give the input, you won't get the exact output. For that, we are going to give some time delay to this microcontroller to function. Then we are going to update the value from our Arduino board. Now you come to the lab portion. See, you can observe one thing. I am not going to do any hardware change. Only program part I am going to change again and again. Okay. So what we have to do? The initial setup and all very same. Only in the loop function I need to do the change. What is the first command? I need to set the cursor in third column of first row. LCD dot set. See, please Observe the syntax. C alone is the capital letter. Okay. So set cursor, set cursor, column number 2, comma 0. Okay. Then what is the statement we need to print? We need to print any statement. What are the statement you have to print? You print it. Okay. Arduino class. Then delay. That's all. That's all. Now you come to the simulation. I am going to start simulate the exercise. Now we will check the output. See, please observe. This is first row of first column. This is first row of second column. These two are empty now. These two are empty now. Then I'm going to start type my statement from the third column of first row. Third column of first row. If I want to move this one, I can move it. See, can anyone help me? I want to start type from the home position. That is first row of first column. What I have to type, can anyone tell? First row of first column. First row, already we have mentioned it as a 0. First column, what I have to do? Very good.
You are typing 0, 0.
0, comma 0. Now you please observe. Now you please observe. This is the home position. By default, my system will start print from the home position. So now I start printing my statement from the first row of the first column. Is it possible to bring the statement in the second row? Yes, it is possible. What modification I need to do? I need to change this row position as 1. That's all. See here. See, the same command, I can print it in the second row also. The third option, shall we print the command in both the rows? That is also possible. What I need to do? What I need to? Please observe the change. Here, I am going to print in the first row. Okay, let me type some other number. Can anyone tell? What is this address? What is this address? Can anyone tell? By the time I will type the second line. 4, 0 means where it will get print. 4, 1 means where it will get print. Can anyone tell? 4, 0. Please respond.
Fifth column, first row.
Very good. Sir, what they typed?
Fifth column, first row. Dhanya
Yes.
typed.
Yes, very good. Fifth column. This 0 means first row. This 1 means second row. See, whenever you want to print the command in 2 lines, first line I gave the address. The same way, give the cursor position to the second row also. Okay. Then immediately start print your statement. One delay is sufficient to print all the statements. So at last I am putting delay 1 second. Now you observe. Now you observe. There is a mistake. Can anyone tell? The full statement not get printed because my starting address I gave it as a 5th column. 5th means after that we have, see, the total column number is only 16. So if I start print from 5th, I need to skip few characters. Please ensure whenever you are typing the program, whether this character can appear in your display, you need to calculate. For that, what I have to do? I need to start print the command little ahead. Okay. Now I am going to print it in my third column. Now we will check whether yes. Can you observe the change? So whenever you start print the command, please count the character. Okay. How many letters are there in your character? Please count. It must be of 16. If it is overflow 16 means it will not get appear in your LCD display. Is it clear for everyone? See, there are a number of functions available in LCD. If we keep on, we teach means that will take 1 or 2 days. Okay. If you have a interest to read that one, please download the data sheet and start read. Many number of functions are available. Okay. These are all few inbuilt functions given in our Arduino sketch. Okay. Beyond this also you can do wonders. Okay. Then so where we fourth one is over. The fifth one. This is the real value. See here. I am not going to type the simple message only. I am not going to print. The real data. I will read it from any one of the system and that I will keep on update my value. If that is the case, how I can print? Please observe the video animation. Setup portion, don't worry, it is very simple. Please observe the loop alone. Here I am going to create one for loop and I have created the variable name called A and I am going to increment the value and I am going to print the value of the A in my display. Please observe the display. It is not a fixed value. Keep on, I am going to update the value. How I can update this? Very simple. Come to your program part. Setup, I am going to skip simply. Loop function, create for loop. For our exercise, I am going to create one for loop and I'm going to set the cursor position. Then I am going to print the value of the particular variable. Then delay. Come here. This is very simple C program. Here I initialized one variable and I give the condition. Then I'm going to increment, set the cursor and start print the value. Shall we check this one? Come. Simply, I'm going to delete this program. Here I'm going to check one small change. The instance of class I'm going to change. All disp. Please observe the change. Disp. If I change the instance of class, immediately I have to change here also. This is not a fixed one. User can give. So disp. Hereafter, wherever I'm going to type the call the function, I need to use this instance. Okay. Here I change the instance value as disp. First, as per our program, for loop int a 0 a any one condition. Here I am going to keep less than 10, then a plus plus. I'm going to increment it single step. Then within the for loop, I need to print. Within the for loop, I need to print. So no longer it is LCD, it is disp dot set cursor, cursor position, home position I have shown that. Now I'm going to change some other position, but it may in the first row only. Okay. Then cursor position, then print the statement. DAS disp print. What I need to print? Shall I type it in double quote and A? Double quote and A. Is it right? Can anyone tell if it is wrong? Please correct me. Else we will proceed with the same and we will check the output. If I print like this, what will happen? Shall we check it now? See, I'm going to start simulate the program. See, here I am getting only the variable name, not the value of the variable. So whenever you want to print the value of the variable means I should not print it within a double quote. Can anyone observe the change? Initially we typed as within the double quote we have typed A. If you type like that, only the A letter will get print. But what I need to print the value passed into the particular variable. So remove the double quote and check. Okay. Very good. So here we can print the continuous value. See why we are typing it in void loop. I need to update this value again and again, not a one-time execution. Therefore, I am typing this particular code into my loop program. Likewise, you can read any real value status. Say example, if you want to read the temperature of the person, you can read the thermometer reading and you can make to print in your LCD display. You can do many wonders with this LCD program. Okay. Now, I will show you one more thing here. I'm not going to set the cursor. Listen, I'm not going to set the cursor. What is going to happen? Please observe. I'm not going to set the cursor position. I'm going to run the program simply. Please observe. Please observe. Can anyone tell what is the change we are noticing now? What is the difference between the previous output and the present output? Can anyone tell? Yes, we are not going to type the value in a single cursor position. That means what? By default, here you need to observe two things. Here you need to observe two things. I will start print from my home position. By default, it will start print from my home position. Immediately, it will shift right and it will print the second character. Please observe here. If you are not giving the cursor position, by default, my character will print in the home position. Immediately it will shift right once and it will start print the value. Okay, those things you try yourself and do it. Okay, the last exercise, please observe. Read a switch and display its status on the LCD. That means what? Very simple. Sir, is it visible, sir? Sir, shall I continue?
Visible,
Is it
visible.
sir?
Yes, visible, Gajan.
Yes, see here. Here what we are going to do means, we are going to read the status of the switch. This is the switch output. I am going to connect it in pin number 6. And what I am going to do means, if my switch is in on condition, I need to make the logic 1 in the display. If my switch is in off condition, I need to make the logical output as 0. Okay. See, I will skip this portion. See the output alone. See, my switch is in off position means logic 0. If my switch is in on position means see 1. Likewise, we are going to read the status of the switch and we are going to print the value. Okay. For that, only one hardware setup we need to include. We will do it one very fast. See, in setup, I'm going to include only one line. Is the new command. Please make a note of it. Here, I'm going to declare the pin number of my switch. Declare the pin number. So pin number 6, I am going to connect the switch. This is alone is the new thing we are going to include. In loop, we have a little program change. Come. In loop, what we are going to do? We are going to combine the two exercise, switch exercise as well as the LCD. Okay. So as usual, I need to read the status of the switch. See, switch status. I am going to read. Why it is digital read? I have connected switch in pin number 6, digital pin number. Okay. Therefore, digital read of the particular switch. Then set the cursor position and type this message first. I'm going to type this message first, followed by, that means switch status, followed by the value of the switch status. It may be 0 or 1. I hope you can understand this statement. I'm not simply going to type the switch status. I'm going to give the message, followed by the message. I'm going to type the switch status either 1 or 0. Okay. Then as usual, delay. Come to our exercise. First we will make the hardware change. for that we need one switch, we need switch and resistor. I kept switch input device, come to input, take the switch. That's all. And now I need to power this board also. Wait a minute. What is the value of the resistor? I need to keep it for switch circuit diagram. Can anyone tell? What is the value I need to keep? It should be a 10 kilo ohm resistor. Okay. I'm going to guys. Ram sir, அது விசிபிளா இருக்குல்ல? டைமர் ஆயிடுச்சு. 5 minutes.
Yes, sir.
2 minutes தான், 2 minutes தான் சார், முடிச்சிடுறேன்.
Visible, sir.
ஒரே நிமிஷம். கொஞ்சம் ஹேங் ஆயிடுச்சு. Yes. See, once I finish this, only you can do your task. That's why I'm unable to skip this portion. Okay. Yes, now it's okay. Give the resistor value as 10 kilo ohm. Keep the switch here. .5 volt ground. Okay. So keep the switch. Rotate the resistor. Yes. So pull down configuration we are going to make. Pull down configuration. Black. That's all. Then here I need to give VCC. That's all. Switch connection. Sorry. Here I should not connect. I need to connect it here. Yes. Pull down. That's all. Now I need to take the output from the switch. So which pin number we are going to use? We are going to use 6th pin. That's all. Sorry. Yes. So pull down configuration. This is output from my switch. The output of the switch is connected to pin number 6. Come to the code portion. What I need to do here, I'm going to declare the pin number int switch is equal to pin number switch. Then loop, what I need to do, I need to read the status of the switch. Then I need to print the value. So read as usual. Read int switch status equal to digital read of pin number is 6. Okay, pin number 6. Then I need to print a value. What is the command? Disp dot print. Simply I am not going to print. I'm going to give the message in front of it. Then only I will come to know what is the value it is getting appear in my display. Okay. Switch status. Switch status. Then the value. Switch status. Then the value. That's all. Don't forget to set the cursor position. If you are not doing this one, you won't get the proper display. Okay, set cursor. Shall we type it in 1,0? Okay, read the status of the switch, set the cursor position, print the message first, then update the value. Here immediately I didn't declare again second cursor position. By default, after this statement, my cursor will increment 1 and then it will start print the particular variable. Now we will observe here. Come back to the exercise. Now my switch status is 0. Why? My switch is in off condition. Turn on the switch. Yes. Now my switch status is 1. Why? I made the switch to on. Turn off the switch. Switch status is 0. That's all. Likewise, you can do wonders with this LCD. Okay. Don't worry about all the exercise. Everything is simple. Do it one by one, then you will get familiar. So at last, please take down the task. Interface a potentiometer. Sir, is it visible, sir?
Yes, Gajendran.
Please take down the question. Interface a potentiometer and display its analog value on the LCD. The experiment is very much similar to the last exercise what we have did. In our last experiment, we read the status of the switch, but here you need to read the status of your potentiometer. Obviously, the potentiometer will produce the analog output based on your wiper position. So connect on potentiometer and read the analog value and make the analog value to print in your LCD display. That's all. Thank you.